Welcome back to the Corporate Flood and Heat Risk Management Program's Flood Resiliency Module Series, developed in partnership between partners in Project Green and the Sustainable Technologies Evaluation Program out of the Toronto and Region Conservation Authority. Module 3, Current Initiatives and Actions to Address Flood Risk. This is the third installment in the four-part webinar series. In these online videos, we will be discussing the impacts that flooding is having across the Greater Toronto Area and beyond, as we are faced with increasing frequency and intensity of storm events brought on by climate change and intensive urbanization. Businesses of all sizes and sectors have a unique opportunity and role to play in mitigating and adapting to climate change through sustainable stormwater management and treatment solutions that not only benefit their surrounding community, but also their day-to-day operations and bottom line. This series will be able to highlight the issues with flooding, their primary causes, how to best protect your business, and support you in finding solutions that help the environment and save you money through protecting your most valuable asset. We hope you enjoyed this webinar series and associated resources. To start today, we'll be looking in today's module, we'll be covering four overarching topics to discuss how TRCA, external parties, governments, and other organizations have developed resources, guidelines, best management practices, or BMPs, and short-term and long-term solutions to flood risk on private property, specifically around ICI properties. Chapter 1, Traditional Flood Infrastructure. In Canada, flood management is the responsibility of the provinces and territories. It is often delegated to municipalities through legislation. Therefore, most flood management activities, including mapping, planning, preparation, response, and recovery, are executed at the local, municipal, or regional level rather than at the provincial, territorial, or federal ones. Specifically in Ontario, the management of flooding hazards, including the prevention and mitigation of impacts, is a coordinated approach by the province, municipalities, and associated conservation authorities. The federal government can become involved if federal disaster assistance is required and used only in extreme circumstances. Management is achieved through a series of provincial acts, regulations, policies, and technical guidelines, all of which, when used together, enable local decision-making processes to take place to both protect people and property from the impacts of flooding. These individual tools are managed by various agencies in the province based on their expertise and creating a network of policies which together implement the flood management program. So when we look at these images, what types of flood infrastructure are there within TRCA's watershed and even in the larger aspect of southwestern Ontario? So when we look at what TRCA and other CAs deploy, here on this slide, we have an example of four distinct types. In the top left, we have the Bolton Dike, which is built along the south bank of the river to prevent floodwater from entering the Bolton core. The structure works in conjunction with a diversion channel to maximize floodwater conveyance levels away from the Bolton core during major events. The top center picture shows the Etobicoke Creek Dike. This dike extension was constructed in 1967 to protect homes on Meadowland Drive and the Brampton Shopping Plaza from flood flows. In the bottom center picture, we have an aerial view of Rockcliffe Smith area with Black Creek Flood Control Channel in the foreground. In the top right image, we have the Tyndale Flood Wall, which was constructed in 1992. This occurred after channel alterations resulted in frequent and severe flooding and evacuations of a nursing home in the vicinity within the 1980s. TRCA undertook flood control works to decrease flood risk from higher frequency events within this area. And the bottom left picture is Clairville Dam. This dam was constructed in 1963 to provide flood control for the West Humber River. The dam has earth embankments with a concrete control structure. The spillway and outlet works consists of 5 radial arm gates. These various examples and many more are just a few ideas of how TRCA and your local conservation authority manage riverine flood flows to better protect your businesses and your property. So what is managed by municipal governments where commercial properties are located? In the MNRF technical guidelines, municipalities are delegated the responsibility for various flood infrastructure works under the Emergency Management and Civil Protection Act, and identifying areas subject to natural hazards, and they are meant to develop management plans, i.e., flood contingency plans, to limit exposure to public health and safety risks. This includes identifying floodplains in municipal plans and incorporating policies to address new development consistent with the provincial policy statement. It is up to a municipality to determine how best to achieve this requirement, and the use of floodplain mapping is one tool available to demonstrate hazard areas. Municipalities can choose to involve their conservation authority in preparing floodplain mapping on the municipality's behalf. Again, only if available to them, meaning they fall within Associated CA's watershed jurisdiction, one of our 36 in the province, but they are not required to do so. Any updated or new mapping is generally funded on an as-needed basis and priorities set by municipalities or through proponent-driven development applications. Neither the MNRF nor the province provides funding for new or updated flood hazard mapping, nor approves new or updated mapping. However, the province has provided small transfer payments for pilot projects related to mapping technologies over the past couple of years. Maps are retained at the municipality and are used for specific land use planning purposes. It is up to the municipality to update their maps when required, which usually is development driven, including updates or amendments to official plans. Municipalities are responsible for municipal stormwater management, a few of which we have here on the slide. This also includes planning, standards, design, establishment, and operations and maintenance. Municipal stormwater management deals with the component of the urban surface runoff that is or would be collected by means of separate municipal storm sewers and in some cases by older combined sewers. Municipal stormwater management can include green infrastructure that captures either partially or fully where snow melts or where rain falls, helping to reduce stormwater runoff that enters municipal storm sewers at their point source. Municipalities also have an important role for managing surface runoff in rural areas. In emergencies, municipalities undertake first response activities and are responsible for recovery efforts in their jurisdiction. So, as we move upward through governing and regulatory bodies, what do conservation authorities manage? Conservation authorities are public sector bodies established by municipalities through the Conservation Authorities Act that deliver programs and services and regulate development and activities set out in regulations within their jurisdiction by using a permitting process if the development may impact the control of natural hazards, including riverine and shoreline flooding, or if activities interfere with a watercourse, wetland, or could cause heavy levels of erosion. Conservation authorities also have a delegated role for the Ministry of Natural Resources Forestry, or MNRF, in reviewing municipal planning documents and applications under the Planning Act for consistency with the natural hazard policies and the Provincial Policy Statement, or PPS. This includes how the development may impact the control of natural hazards. These responsibilities include policy interpretation and the transfer of data, information, and science to municipalities, the delineation of hazard areas through mapping and supporting hydrologic and hydraulic studies provides important information and science to support these delegated responsibilities. Regulatory mapping may be updated by a conservation authority from time to time. Sometimes municipalities update their official plans and their floodplain mapping, or as a requirement of a permit application, a proponent may be required to update authority regulatory mapping. Where the province's 36 conservation authorities have been established, they are delegated with the responsibility for flood forecasting and warning. Where no conservation authority exists, the local MNRF district is responsible in this case. Supporting both CAs and MNRF districts is the MNRF Surface Water Monitoring Center, whose main function is to monitor water flows and levels, assess conditions across the province, and provide communications and ongoing knowledge of the provincial flood potential at that time. The scope and complexity of a flood forecasting and warning program for a particular jurisdiction is contingent on a variety of considerations, including the level of risk within flood-prone areas. Some conservation authorities, like TRCA, may operate and maintain an additional network of stream flow, snowpack, rain gauges, and climate stations throughout their geographical jurisdictions that can also serve as data inputs to their hydrologic models to address the specific needs within their associated jurisdiction. As we've discussed in the past modules, delegated by the province, conservation authorities are mandated to operate a flood forecasting and warning program, which includes the following activities: operating a flood forecasting and warning system, issuing flood messages to municipalities, the public, and media in a timely event, operating conservation authority owned dams, providing advice to municipal partners and stakeholders when it comes to flood risk and flood vulnerability, and maintaining communication and liaison with municipal and other partner agencies. Now, to address the image above, what these various images are showing is one of TRCA's flood control structures that we manage. Located on the west side of the Don River and upstream of Lakeshore Boulevard, the West Don Lands area of downtown Toronto lies within the floodplain of the Don River. Before revitalization and development could occur, the area required flood mitigation. In 2015, an oversized dike, highlighted in orange here on the map, was designed to withstand all failure conditions. It was constructed to wrap around this area, shown here in light blue. The West Don Flood Protection Landform removes flood risk and allows the redevelopment of this area in the form of residential and commercial buildings. The image down below shows a profile view of exactly what encapsulates this dike down in the Donlands. And the picture here on the right by the American Society of Landscape Architects shows how this dike system currently looks today in Toronto with all that green space. Now, finally, what is managed by the province and federal governments? Flooding is predominantly managed by the Ministry of Natural Resources and Forestry, or MNRF, at the provincial level. They collaborate and work with conservation authorities and Environment Canada at the federal level to forecast when and where flooding will likely occur within the province. The Ministry of Natural Resources and Forestry is the provincial lead for flooding, but additional provincial direction is provided by the following different groups: the Ministry of the Solicitor General, the Ministry of Municipal Affairs and Housing, the Ministry of Infrastructure, the Ministry of Transportation, the Ministry of Agriculture, the Ministry of Food and Rural Affairs, and the Ministry of Environment, Conservation and Parks, based on established roles and responsibilities for each. Of these agencies mentioned, we'll talk about three in more detail. To start, we'll talk about the Ministry of Municipal Affairs and Housing, or MMAH. In their role as lead agency for the administration of the Planning Act and the Provincial Policy Statement, or PPS, the MMAH supports the MNRF through inclusion of hazard policies in the Provincial Policy Statement for new development and redevelopment of sites for commercial, residential, and institutional and industrial properties. The MMAH also delivers the Disaster Recovery Assistance for Ontarios, or the DRAO program. This is used for private property owners. And at the municipal level, the Municipal Disaster Recovery Assistance, or MDRA program, for eligible expenses following a natural disaster like a flood that could damage a property. Second, the Ministry of Infrastructure's connection to flood management and prevention is the MOI is responsible for making recommendations on priorities for infrastructure and effective coordination of infrastructure across provincial ministries within the government. The MOI works with partner ministries and Infrastructure Ontario to design, implement, and administer public infrastructure programs. The Ministry of Infrastructure manages the asset management planning for municipal infrastructure regulation, or OREG 588/17. This guides asset management and provides tools and support for municipalities in Ontario to meet their current and future infrastructure needs. Finally, the MNRF manages Ontario's flood map, as seen here on the right. This provides up-to-date local flood messages on Great Lake water levels, Great Lake storm surge warnings, and riverine flooding potential in line with the province's conservation authorities. The MNRF also commissioned and developed the province's Ontario flooding strategy in 2020, based upon recommendations provided by Ontario's Special Advisor on Flooding back in 2019. His name was Douglas McNeil, PN from McNeil Consulting Incorporated, out of Winnipeg, Manitoba. The province conducts flood forecasting and warning via the MNRF Surface Water Monitoring Center, which we mentioned previously. This system monitors weather, rainfall, and stream flows, as well as provides advisories and a suite of products and tools. This includes weather panels, snow survey reports, etc., to conservation authorities, municipalities, and MNRF district offices on flood potential within their area. The monitoring of flood conditions occurs 7 days a week, and the province is able to contact conservation authorities and other stakeholders immediately with updates. Local scale flood forecasting and warning is provided by MNRF district offices and conservation authorities, as we talked about before. Many of the conservation authorities, like TRCA's publicly available gauging system tool, conduct more detailed flood forecasting and warning for their respective jurisdictions, which we have available and which we actually went over and mentioned back in Module 2. The Ontario government guides stormwater policy and land use planning, and the federal government administers disaster relief following flood events. Asset management will be required in order to assess provincial infrastructure funding from senior levels of government and provides an opportunity to begin this analysis of current infrastructure conditions and future targets, as well as providing an opportunity to begin the necessary analysis of current infrastructure conditions and future targets. These asset management plans will ensure that adequate funding, which may include a dedicated stormwater fee or another funding mechanism such as a local improvement charge or LICs, or known as development charges, is provided to achieve these set targets. The MNRF continues as lead administrative ministry, having overall government responsibility for natural hazard management policies and programs. Recovery includes actions taken to recover from a flood emergency, such as the use of disaster financial assistance to restore property to pre-flood conditions. Provincially, financial assistance is delivered through two programs: the DRAO, program for homeowners, tenants, small owner-operator businesses and farms, and not-for-profit organizations, and the MDRA, which we mentioned as well previously, program for municipalities at large. These programs provide funds for eligible expenses following a natural disaster to help Ontarians and municipalities recover from these extraordinary costs. Finally, as we look towards the federal government, the Canadian Constitution Act and Provincial Water Management Authority is derived from the authority to legislate over property and civil rights over matters of local and private nature, and over local works and other natural resources. Some federal governments, such as Natural Resources Canada or NRCan, also have a role in flooding and other natural hazards. NRCan monitors natural hazards, including flooding, landslides, and so on, and provides information about hazard events as well as information to help Canadians understand and prepare for natural hazards and to reduce the losses from hazard events. NRCan develops and distributes geospatial data, topographic and geoscience maps, images, and scientific publications associated with flooding and landslides. Public Safety Canada administers the Disaster Financial Assistance Arrangements Program, or DFAA. This reimburses provincial and territorial governments for eligible disaster response and recovery costs. With flooding being the single largest draw on DFAA, NRCan initiated the Federal Flood Mapping Guidelines Series in partnership with Public Safety Canada to provide critical support to areas in Canada that didn't necessarily have robust guidance related to floodplain mapping. Under this program, the federal government shares costs with provinces and territories based on a sliding scale per capita formula. Ontario, as the largest province, has the highest threshold for federal funding and consequently is eligible for the DFAA much less frequently than most of the other provinces. Based on the current formula, which is adjusted for inflation each year, Ontario could access federal funding under DFAA only in the event of a disaster costing the province in excess of $46.2 million, of which flooding does top over quite regularly. Ontario has only qualified for DFAA 3 times in the relatively recent past: for the 1998 ice storm, the 2004 Peterborough flood, and the 2013 ice storm. As a result, disaster financial assistance costs associated with recovery are funded almost entirely by the province itself, although the overall financial burden for disasters is borne to a great extent by municipalities and property owners as well, showcasing the importance of prevention, mitigation, and adaptation practices to be used. Public Safety Canada also provides funding for cost-shared projects related to the management of flooding and other natural hazards through programs like the National Disaster Mitigation Program, or NDMP. Meanwhile, Infrastructure Canada provides funding through the Disaster Mitigation Adaptation Fund, DMAF. Flood-related infrastructure projects may also be eligible for funding under the Investing in Canada Infrastructure Program, or ICIP, under the Green Stream, administered jointly by Infrastructure Canada and the Government of Ontario. All of which we just talked about right now can be shown by this sliding scale and circular graph showcasing when a flood event occurs, the response that takes place, recovery processes that then take place, mitigation to make sure that the event does not happen in the future, or if it does, it's minimized heavily, and then preparedness for the next time. And associated with each of these are each of the associated groups either at the provincial or federal level, as well as conservation authorities and municipal partners, as well as other partners at the regional or municipal level. Chapter 2, Flood Protection Resources. This picture was taken by the TRCA showing flooding at Jane Street, south of Steeles, which flooded heavily on August 9th in 2011. So when we talk about resources, there's numerous ones to go over, and a large percentage of them are focused mainly at residence and residential lot level protection. But a lot of these resources focused on residents and property owners in the residential stream can also be amended for the ICI sector. So here's a great example from the Intact Center on Climate Adaptation of the University of Waterloo. Listed above are some resources, as we talked about before, that can easily be adapted for commercial properties. Here are just a few of these resources from the ICCA, as I mentioned before, which is funded by Canada's largest insurer, Intact Insurance. The first example is Water Resistant Building Materials document. This can be used for both residential and commercial properties and highlights a number of third party and proprietary devices and adaptive actions and methods that can be used around your property. The Home Flood Protection Checkup app is a step by step online yes or no questionnaire that then generates a customized report for you based on your responses. That can also be used for commercial properties based on each of the sections. The Home Flood Protection Handout document is used across Canada in ICCA's outreach programs and is based on the easiest maintenance practices all the way down to more complex and complete upgrades that may require the hand of professional plumbers, engineers, or contractor personnel and cost more. And these examples are installing more window wells, correcting grading overall your entire property, installing a backwater valve on your sewer lateral or storm sewer lateral, and installing backup sub pumps as well as a backup battery pack. We'll get into this more as a lot of these actions can also help you reduce your insurance payments on your insurance policy each year. Another example, focused on residents but can be amended for the ICI sector, is a list of flood emergency preparedness guides provided by Partners for Action, another research group out of the University of Waterloo that focuses on flood risk and is funded by the Cooperators and Farm Mutual Re. They have put together a list of emergency preparedness and recovery documents, of which can be relevant to commercial property owners as well as tenants. They have also put together a list of 8 different business continuity resources for small, medium enterprises, or SMEs, and larger corporate and industrial businesses, some of which include the City of Calgary and the region of Wood Buffalo in Alberta after their catastrophic flood event in the summer of 2013, one of Canada's most costly natural disasters that have occurred. We can also focus on what insurance companies are offering. The Cooperators provides details for the average consumer to understand their flood policy and their coverage requirements on their portal site. This site on flooding discusses coverage in Canada and how to potentially qualify for annual discounts on your policy by adopting adaptive actions such as employing a backwater valve or backflow device on your lateral, as well as a backup sub pump power supply and installing flood alarms to ensure you know when flooding or a major leak occurs in your home. Furthermore, they also provide users with a water risk assessment. This tool highlights how water can get into your property and what coverage you require to insure you for those associated damages caused by the given type of flooding mentioned. This risk assessment tool also provides you your current risk level based off of your local geographic location and former claims made in your area. We can also look at resources focused on commercial property and ICI sector as well from these residential properties. Above is showcasing adoption rates of property level flood protection measures, or PLFP. A 2016 survey conducted by Partners for Action from the University of Waterloo found that about 30% of Canadians have adopted at least one form of PLFP listed here on the graph above. This can include grading your property away from the house. This could include lifting and removing expensive items from your basement floor and putting them at higher levels, either in the basement or higher levels within your home, installing a new weeping tile, sub pump, elevated electrical or HVAC components, new backwater valves, water resistant materials, and so on. Now, the uptake of PLFP measures remain generally low, though, amongst most homeowners, and the survey found that low levels of responsibility of property owners is what likely contributes to these poor uptake rates because they don't really understand whose responsibility it is, and that education needs to be put out there more. As can be seen above, most practices either took place by the previous owner themselves or were simply not completed by the new owner. This is where resilience and preparedness need to be communicated better to not only residential property owners, but commercial owners as well. Some municipalities encourage the uptake of these PLFP measures through various economic and bylaw interventions. For instance, Toronto's Basement Flooding Protection Subsidy Program or Windsor's Basement Flooding Protection Subsidy Program both offer in or around about $3,000 per property towards the cost of installing either a backflow prevention valve or sub pump to protect against flooding caused by extreme precipitation. Alternatively, in Calgary, the drainage bylaw there requires that downspouts must be positioned 2 meters away from any roadway to divert stormwater from the storm sewer system and be drained naturally down and infiltrated into green spaces. Residents must keep any surface drainage instruments, such as swales, clear of debris as well within this bylaw that was instituted by the City of Calgary's Water Services back in 2005. The insurance industry has enabled critical research and its translation into practical guidelines for property and community level protection measure and offers incentives for further risk reduction through reduced premiums, as we talked about before with the cooperators. Programs like this should be aimed more directly at larger property owners, such as those within the ICI and MUR industry, to ensure higher levels of excess overland flow does not impact neighboring businesses or their own workers on their site. Third-party adaptive measures. Previous research has concentrated largely on residential property and has not considered the variety of international risk disclosure, insurance, and regulatory requirements for larger commercial and MUR properties. Most research in property level flood risk mitigation has been directed at said residential properties. However, many of these level measures designed to prevent physical damage may also be appropriate for small commercial premises, as we just talked about, while measures designed to protect smaller communities or neighborhoods could be applicable to larger scale properties. Research out of the United Kingdom has found that understanding of geographic and general flood risk mitigation adaptive measurements amongst built environment and building operators, building owners, and tenants is currently lacking and needs to be made more available. With the ability for these professionals to understand what is at risk, what mechanisms and tools are currently or soon to be available to them will help better protect their investment, their workplace, their place of work, and or their own business. Here on the slide above, we have an example of a bunch of different adaptive measures, some of which we've already gone over. Uh, from the left going to the right, we have Cupelix, which allows the raising of a floor to allow water to pass through if there's seepage or groundwater below, and make sure water does not enter through the bottom of a company's business. Here in the middle, we have a backup power generator lifted above the local flood line. To the right, we have an easy flood barrier that can be deployed fairly quickly in the event of a major storm event or flood event occurring within doorways and even windows. In the bottom left, we have industrial setup of a sub pump system. In the middle, we have another flood barrier out of Oxcam Pathfinders project, highlighting an example set out in the UK. And then to the bottom right, we have another example of a deployable flood barrier that can be put around a large commercial property as shown by Aqua Barrier here in 2021. A lot of these third-party measures are widely available and have been used across Canada. We'll be going through a few case studies showcasing them and when they were used. So when we talk about property flood resilience measures, there's a lot of work that can be done. Chiao et al. Wrote a paper discussing improving the flood resilience of commercial buildings through property flood resilience measures. This is shown here at the table to the left, which came out of their paper. The purpose of applying these kinds of resistant measures, i.e., dry proofing, or meaning to keep water completely outside of the building, can be seen here in the left column. Uh, these resistant measures for commercial property is to make sure it's as watertight as possible to floods, and the floods in particular are ones where outside standing water is not extremely high. For example, no more than 60 centimeters or just over half a meter during limited durations, meaning it only lasts for a few hours. This strategy will help to reduce damage to the internal fabric of the building and its contents. This can include equipment and machinery, staff, customers, as well as suppliers' records, thus reducing the associated stress and suffering to businesses as well as their users and owners. These measures provide property owners the opportunity to relocate important items to a higher, safer level out of the likely scenario of a flood occurring high enough where it could damage those various assets. Any openings left unsealed serve as a passage for floodwater to enter into a building, meaning that the resistance approach fails and the resilience approach, also known as wet proofing, where water is expected to enter the building, must be employed instead. Work has been done to identify these potential points of water entry, mainly in residential buildings, and some of these findings can also be applied to commercial properties with similar features. In an ideal case, floodwater would be fully kept out of the buildings. However, this may expose the building to structural, hydrostatic pressure and risks in extreme or prolonged situations. These resilience measures can be integrated into the building's fixtures and building materials, meaning adopting the likes of cement board instead of plaster or drywall, raised outlets, sub pumps, and etc. This allows for quicker restoration and return to business in the case of flood damage. Another example of using a resilience feature is shown here by Fujilift from 2023. A great example are flood alarms, where sensors are placed at the bottom of an elevator to ensure that if a flood does occur, there's a control panel which instructs the cabin to move to a safe floor. Once the cabin arrives to a safe floor, the door will open and usage is forbidden to ensure passenger safety so they can't go back inside. There's a voice saying the elevator is flooded and do not use, and will send a signal to the control panel, lifting it above the flooded floor, in this case, in the pit of the elevator that's being detected, as well as the first floor flooding currently, and will allow users to rise back up to the second floor or higher. This is currently employed in several different businesses across Canada, as well as internationally. Another full scale example of this is what was provided by the MDA Community Flood Consultants. Um, Combined resistance and resilience measures, as we just talked about, or wet and dry flood proofing, allows water to stay out of the building as long as possible, and buys valuable time to raise and move furniture and equipment, as can be seen here in this graphic. As we go along, we can see the difference between resilience as well as resistance factors, and there's a lot of examples of both. A great example, which we'll be talking more about in Module 4 in our final module within this series, is adopting sustainable urban drainage facilities. And this can include measures such as landscaping grounds and including things like low impact developments and green infrastructure, such as planting trees, installing rain gardens, swale systems, bioretention cells, or permeable pavers, as seen here at the bottom left. Examples of sub pumps, as well as non-return valves or backwater valves, are another example of that wet flood proofing that can also be used, as well as flood barriers protecting main entrances, as an example of having a resistance factor built into your property. This is a great overview of seeing what a commercial property could do best in terms of best practices to deploy both wet as well as dry flood proofing or resistance and resilience measures at the property level. When we're looking at case studies of how some of these third-party systems have been deployed in Canada, we have two great case studies that were used out west, both in Alberta as well as Vancouver. The picture on the right is from Fort McMurray, Alberta. This is showcasing Keano College, located in Fort McMurray and nestled in between the Athabasca River and Clearwater River, shown here on the Google Map image to the right. In the spring of 2020, the college and its surrounding campus had $55 million in property damages resulting from a major riverine flood. Flood restoration of critical infrastructure on campus and its buildings were completed by mid August that same year, with ongoing remediation occurring afterwards. As a result of these costly damages incurred by the college, they were not able to obtain overland flood insurance coverage, an optional coverage only recently available across Canada, 2015 onwards. As a result, Keano College is developing a flood risk management plan and adopting various adaptive and resilient measures to better protect their Clearwater campus. They are working in concert with their flood insurance broker and insurance provider to develop a list of short-term and longer-term solutions to their flood vulnerability. All of the buildings located on the college's Clearwater campus are within the river's 1 in 100 year floodplain. So the college is working with the regional municipality of Wood Buffalo, Canada's largest regional municipality in terms of landmass, and their current flood prevention strategies to be deployed at the college itself. One said short-term strategy is that of the Tiger Dam flood barrier system, seen in the picture on the left in orange. The college evaluated various short-term solutions and had opted to acquire the Tiger Dam flood barrier system. The system can be filled in just a few minutes per 50-foot section and at 2 feet high, with a motorized pump or directly from a water hydrant nearby, and replaces 500 sandbags per section. These various sections can be joined together and can be stored when empty by rolling up and can be used multiple times, unlike its sandbag counterparts, as shown here on the image from, from the Vancouver Board of Parks and Recreation. The Tiger Dam system will be deployed in April and timed with the river breakup, meaning ice breakup. The college will conduct an annual exercise of deployment as part of our emergency preparedness. This was said by Dale Mountain, the former president and CEO of Keano College. The longer-term solution for the campus includes the construction of fixed barriers and changes to storm and sanitary sewers, along with improving their water evacuation pumping system nearby. The college will continue working with Alberta Advanced Education and Alberta Infrastructure to protect the college's infrastructure while collaborating and complementing efforts of the local regional municipality of Wood Buffalo. The picture here of Keano College can be seen as it's seen an aerial view of it today, and you can see it being surrounded, the Athabasca there on its right in the circular image, and just at the top left, you can see, my apologies, the Athabasca flowing to the left of the college at the top left, and the Clearwater River there to the right of it. The second example we'll be going over was from Vancouver, BC. The photo on the left shows a picture provided by the Vancouver Board of Parks and Recreation, who installed a Tiger Dam as well, which is a deployable barrier back on January 20th this year. They deployed it around a government-owned pool facility, or KITS Pool, in the city of Vancouver to protect the facility's mechanical room during an expected king tide event, which is when tides are at their strongest and highest, occurring normally between November and February. As we can see, these systems can be deployed in very large institutional and commercial sized buildings and can be deployed anywhere across Canada. Chapter 3: Flood Management Guidelines, Plans, and Planning with a Climate Lens in Mind. So, what tools, guidelines, and plans are made available to commercial property owners? It seems, as we've talked about before, there's a lot of focus on residential properties. But what can we look for in terms of what can be focused on for larger commercial or ICI properties? So, here's a few examples we'll be going over. The Climate Adaptation, Resilience, and Commercial Real Estate document by CSA was released earlier this year in March 2023. This resource will be made available on the PPG module page and will be referenced in the final module. Infrastructure Canada's Climate Lens. This new style of looking at infrastructure and designing it to be more climate resilient is an example of their risk vulnerability matrix decision-making process and table when building new climate resilient infrastructure. Their simplified table can be seen here in the bottom left, focusing on consequences versus likelihood. You can have a very high consequence, but almost low or no likelihood of it happening, and it's not a major issue. Versus you have a very high consequence, meaning high cost meaning to people's lives, to people's businesses, their livelihoods, or their properties, and you can have the likelihood be very high. That means you're at extreme risk, and work to ensure you're having a climate lens being approached, especially in a new development, needs to be considered going forward. Furthermore, we have a neighborhood business zone co-benefits development guide. This was written by the Toronto Region Conservation Authority in combination with the University of Waterloo. And this paper focuses on how neighborhoods can benefit from green infrastructure and LID design planning. If you remember before, we talked about how a lot of neighborhood planning and community planning can also be used coincidentally with larger commercial or ICI properties. Furthermore, the schematic of the office building shown in the bottom right is from the Boston Coastal Flood Resilience Design Guidelines and Zoning Overlay District. This was developed by UTILE and is applied to existing and future developments within the Boston area, ensuring buildings are built or adapted to withstand the flooding risk posed by sea level rise and associated storm surge flooding. These new changes will be enabled by a future zoning overlay, which covers areas with even a 1% chance of coastal flooding up to the year of 2070. This schematic was featured in the Urban Land Institute's Resilient Retrofits Climate Upgrades for Existing Buildings document that was released in late 2022. The schematic shows a long-term plan for buildings which incorporate resilient elevators, as we mentioned before, with flood sensors installed, sub-pump systems, backwater valves, temporary flood barriers on windows and doors in impending storm events, proper parging and reinforcing of older heritage buildings due to hydrostatic pressure, and updating HVAC systems to be sited out of the basement to limit the likelihood of flooding from sea level rise design flood elevation, or SLR DFE, as it's referred to, further damaging the system over the coming decades. So one of the first examples we'll look at is provided by the SCC and CSA. The CSA is the Canadian Standards Association. This group is accredited by the SCC, or the Standards Council of Canada. The SCC is a standards development organization. It is also accredited as a certification body, and CSA is a nonprofit membership association serving industry, government, consumers, and other interested parties in Canada, along with the global marketplace. The CSA invites leading experts in various fields, be that healthcare, science, construction, economics, trade, mechanics, etc., to sit on expert committees to create new guidelines and standards to help move their associated industry and sectors forward. The CSA also develops standards and research publications, as well as featured articles, backgrounder documents, brochures, and program overview documents on their website. Shown above on the slide are 5 CSA associated documents. The 4 on the boundaries are 4 guidelines and standards associated with flooding, and the one in the middle is what we referenced before and is a standards research document and backgrounder. Each of the above documents include topical information relevant to commercial properties on how they can make their businesses more resilient to flooding, and links to these documents will be provided on the PPG module site. The first is CSA W211-21. This is a standard providing requirements and recommendations for the management of stormwater systems that ties in a risk-based process for decision makers based on a changing climate and increased flow due to higher levels of urbanization, and is aimed at not only municipal government owners and operators, but towards builders and developers who should factor improved stormwater management and climate resiliency into their infrastructure design and construction on their own private properties. This management standard for stormwater systems can provide guidance around planning, design, and the proper construction of stormwater systems as we move into a future with a changing climate. CSA W210-21 is a prioritization of flood risk in existing communities. This standard focused on guidance for flood hazard and vulnerability screening within existing areas comprised of residential and mixed-use buildings. The guideline highlights the importance of mitigating both climate change and land intensification through urbanization with appropriate stormwater controls at the property level as part of integrated land use policies in communities. This standard is aimed at municipalities and conservation authorities, but also businesses and development communities to better protect their investment without a properly planned for flooding in its many forms, be it overland, riverine, storm or sanitary backup, infiltration, and lake level rise. CSA W20419, or Flood Resilient Design of New Residential Communities, is a standard providing an approach to better design new flood resilient communities and includes applying the user with updated intensity duration frequency curves, or IDF curves, that account for a change in climate. Although aimed solely at residential homes, it also includes details that can be used for mixed use residential development with small commercial and institutional usages, along with multi use residential when applied appropriately. CSA Z818 is the standard and is meant to update mitigation techniques that can be readily applied to commercial and other ICI properties for basement flood risk, as an addition to the National Building Code of Canada, or NBCC, Part 9 for residential buildings. The standard is based off the C document guideline we mentioned in Module 2 for basement flood risk out of the Institute of Catastrophic Loss Reduction, or ICLR. The guideline provides an 80-point visual inspection on things to amend and different actual items which can be employed, whether by the owner themselves or a hired contractor. And finally, we come to the CSA Commercial Real Estate Standards research paper that was released earlier this year. The commercial real estate, as we've mentioned before, is at risk without the adoption of adaptation measures. And this research paper highlights actions, plans, and policies that can be put into place to better protect and ensure optimal business continuity, support of tenants, protection of future and current investments, as well as long-term value of the property, while also aligning resilience and adaptive measures with most businesses currently enacting ESG disclosure frameworks and evolving best practices. The paper develops shared resources and how to get over common barriers met by most commercial building owners and operators, and shares a commercial business specific toolkit to support planning with resilience and adaptive management in mind. As we move forward, what does TRCA and CBC as conservation authorities do with some of these plans and policies? The first of which is the document on the left, the Making Green Infrastructure Mainstream document. And this paper talks about the importance of making the business case for stormwater infrastructure to be installed on both public and private properties. Many Canadian municipalities have begun building GSI, or Green Stormwater Infrastructure programs. This document describes the efforts of 4 such organizations through individual case studies. Each organization has financial, environmental, and social reasons for using GSI to address stormwater management in their legacy developments, urban areas built before flooding or water quality controls became requirements for that development. Each case study presents the GSI solutions developed to address their stormwater management problems that are common to most Canadian municipalities. In the document, the Southdown case study specifically presents the results of a technical and financial feasibility study conducted by Credit Valley Conservation, or CVC, in Mississauga's Southdown District, an industrial, commercial, and institutional neighborhood in southern Mississauga. This study examines whether incentivized GSI retrofits on private industrial and commercial properties are a financially feasible alternative to traditional stormwater measures on public property alone. The results showed that GSI retrofits on private property would cost about $208,300 per hectare over a 50-year period, while traditional stormwater management ponds on public property would cost $378,400 over the same time frame. In addition to the cost savings, the GSI retrofits on private property would provide a higher standard of stormwater management and a host of other co-benefits as it's located at site. Ideas within this case study showed incentivizing communal GSI retrofits on private property and communal GSI retrofits is a technically and financially feasible approach for municipalities to improve their stormwater management in their legacy development areas. Building a proof of concept in Mississauga's Southdown neighborhood is the next step. You can see the Southdown case study for further details, and we will link this resource as well on the PPG Module Hub. An example of this being used and deployed already today can be seen in Philadelphia, Pennsylvania, in the US. The Philadelphia Water Department quickly found that offering stormwater fee reductions to landowners who implemented source controls was an inadequate financial incentive. The upfront costs of GSI measures were too high for the annual stormwater fee reductions to provide a reasonable payback. To address this low uptake, the Water Department began the Stormwater Management Incentives Program in 2012. This program offered rebates to landowners to offset capital costs, While Philadelphia was initially spending $250,000 to $300,000 US to green 1 acre of publicly owned property, it cost them only $100,000 per acre to green private industrial and commercial properties. This was found by Valderrama and Davis in 2015. Despite this, the program only approved 36 applications during its first 3 years, which is fewer than expected. The Philadelphia Water Department quickly found that offering stormwater fee reductions to landowners who implemented source controls was inadequate, as we talked about before. The upfront costs of GSI measures were too high, and because of this, they looked to focus more on building off these 36 applications. Once the facilities instead are built, landowners qualify for annual stormwater fee reductions up to 90%, as Philadelphia uses a stormwater fee program. Incentive programs geared toward lowering capital costs for GSI retrofits on private property are increasingly common across the USA and are more proactive and are more popular for the private landowners themselves. Only a few Canadian cities have experimented with incentive programs, though, and these have generally focused on lot level measures for residential homeowners, example using rain barrels. Whereas the above table on the right is from a different document from the Thornhill Sustainable Neighborhood Action Plan, developed by TRCA Sustainable Neighborhoods Action Program, also known as SNAP. The SNAP team, through their action plan report for Thornhill, found that various projects and programs, already legacy initiatives within New York Region, Vaughan, and specifically Thornhill, could be supported through tree plantings and the adoption of green stormwater infrastructure, or GSI. This can be done on private properties and for the city to set up a performance monitoring plan with an associated feasibility assessment and evaluation framework that could promote these adoptions for ICI properties. By greening and humanizing multi-use residential and ICI properties, numerous co-benefits can be tracked through outcome indicators that support the city's and the larger region's current initiatives. We can see this example for example 3, which is found in the Thornhill Sustainable Neighborhood Action Plan, showing what the output indicators are and how all of these can impact energy and climate, stormwater management and water efficiency, as well as percentage of residents satisfied, the liters of water saved, and tons of waste diverted from the landfill. And the mention of these can be already used in legacy documents and legacy programs. The programs here are shown on the right with the different divisions working on them at Thornhill. So a neighborhood action plan like this for ICI properties can be easily implemented. Another example of this, as we were talking about Southdown, shows how for that case study, they went through various pieces of cost sharing among benefiting stakeholders and aggregating private commercial and industrial properties for communal GSI retrofits. This would save money through communal systems on private property, which are more cost effective than centralized stormwater management. So all this work goes to say that ICI properties can be a great resource where a lot of these stormwater management systems can be deployed. And municipalities have to do a better job of getting these ICI property owners involved and invested in developing some level of GSI and adaptive management on their private properties. Now, looking forward to what the Insurance Bureau of Canada did with their National Action Plan. IBC proposed the following action plan focused on flooding and flood insurance to the federal government in 2019. After 17,000 plus homes were flooded in the spring of 2019 in both Ontario and Quebec, Trudeau instructed his cabinet ministers to increase priorities and begin implementing the plan provided by the Insurance Bureau of Canada. As can be seen above in the flowchart table, this has 6 different elements designed to either move and or make more resilient and adaptive properties located in the highest risk areas in coastal or major fluvial flooding zones. The remaining areas would be appropriately defended and insured where policies are more affordable due to a lesser risk. Currently, a national plan or strategic retreat for homes at the highest risk of coastal flooding is currently in development and in consultation with both provinces and territories. At the moment, this program has been implemented in 2023 and is in the federal budget for $31.7 million over 3 years, but only protects households at this moment, as of now, that's at risk of high risk of flooding that either can't obtain due to high risk exposure or can't afford exceedingly high insurance coverage for flooding. This program, which will include some level of pooled funding for those highest at risk, will take a page likely out of the United Kingdom's flood program or flood reinsurance program and France's public reinsurer Caisse Centrale de Reassurance. Furthermore, the 2023 federal budget also highlighted a proposed $15.3 million to go towards a publicly accessible online portal for all Canadians to access information to their flooding exposure. This can include details for MUR and ICI property owners as well. It can include details about hazard risk, vulnerability within their geographic location, and best adaptive measures that can be deployed that's generated by the federal government. Well, we move forward, we look at the Climate Risk Institute and what they do with PIVC, their IRP designation, and the RROIT tool. The Public Infrastructure Engineering Vulnerability Committee, or PIVC, was created in August 2005 to conduct an engineering assessment of the vulnerability of Canada's public infrastructure to the impacts of climate change. Between August 2005 and June 2012, the committee's activities were co-funded by Natural Resources Canada, NRCan, and Engineers Canada. As of March in 2020, operations of the PIVC protocol and PIVC program have been assumed by the PIVC Program Alliance, which consists of the Institute of Catastrophic Loss Reduction, ICLR, the Climate Risk Institute, CRI, and the Dutch Gesellschaft für Internationale Zusammenarbeit, or GmbH, which operate the program internationally overseas. The protocol was first used in 2007, and as of 2022, it has been implemented and used 150 plus times over in Canada to assess various scales and types of infrastructure. It has also been applied in Costa Rica, Honduras, Brazil, Vietnam, and Lesotho. One key benefit of the PIVC process is its flexibility. It has been used to assess climate vulnerabilities and risks across a wide range of infrastructure systems in Canada as well as internationally. It can evaluate green infrastructure systems and inform the development of nature-based solutions to address climate resilience as part of a broader built infrastructure assessment, or the PIVC Graded Green Protocol, which is currently in development for this said reason, and supports both top-down climate data-driven and bottom-up scenario analysis driven climate risk. Whereas top-down assessments include those that rely on future climate scenarios and climate change projections to identify vulnerabilities for future climate conditions, the bottom-up assessments rely on realistic scenarios, example, extreme event occurrences which have occurred or are likely to occur, generated by the assessment project team. These scenario-based assessments may be used where reliable future climate projections are considered unavailable for specific assessments or systems within Canada. Meanwhile, the Climate Risk Institute, or CRI, in partnership with Credit Valley Conservation, have also developed the Risk and Return on Investment tool, or the RROIT, which is shown above with inputs provided on the magnitude and frequency of storm events causing flooding and the percent risk reduction from various management options and life cycle adaptive measures. These can include low impact developments, green infrastructure, or third-party flood adaptive infrastructure measures to highlight the rate of return on your initial investment with a payback period. The RROIT is currently being redeveloped and updated and will soon be available as an open source and free desktop software that will be able to perform the following key functions. The tool will be able to provide regional climate change projections, assess baseline flood as well as erosion risks associated with extreme rainfall events, and quantify the potential damages to private and public infrastructure, as well as vulnerable populations under current and future climate scenarios. It can also evaluate and compare risk reduction achievable by management options, example, gray and green stormwater infrastructure, land acquisition, and flood proofing measures, as well as adaptive actions. It can perform a financial assessment of the return on investment associated with each or combination of various management options by comparing life cycle costs to the benefits, i.e., the associated cost savings. This can be achieved by reducing flood risk under various climate change scenarios. It can also identify high-risk areas that consider social, health, infrastructure, and environmental vulnerabilities among populations, and can assist users in understanding maintenance needs to inform asset management planning and design a monitoring program. So a quick overview of how the tool works shown here on this flow chart shows a magnitude frequency of storm events, costing a total flooding cost of baseline conditions, going down to a total save by reducing flood risk if the percent flood risk from their management option is updated, and your life cycle investment in the management option showcases your rate of return for your initial investment for your adaptive practice, as well as the net present value and the payback period. In the next example, we can see an outline shown here on a demo project by the ROIT, which shows buildings highlighted in red that can show those buildings that are at risk from major riverine flooding. As you can see, as we go down along the left here in the table of contents for the tool, you can also see there's examples of urban overland risk that can affect health or critical infrastructure and bridges at the asset level for the municipality. So all these can be clicked, and obviously more of these buildings within this screenshot would be highlighted so that you would see how much more at risk various buildings are at from different types of flooding, be it sanitary sewer backup, be it urban overland, or be it riverine flooding. The tool, when released, will include a user-friendly web-based interface and will prompt the user for data regarding the relationships that exist for their specific water infrastructure systems. We will include a YouTube video of how this tool works so you can go through it at your leisure. Finally, the Climate Risk Institute, or CRI, has also developed a credentialing program entitled the Infrastructure Resilience Professional, or IRP. This is based out of Royal Roads University. The IRP program is aimed at engineers in Canada who must complete 6 courses total and demonstrate current experience in their day to day work of climate change and infrastructure initiatives, programs, or projects, as well as being a licensed professional engineer. The courses are aimed at professionals in the climate change industry who are involved with planning, procurement, design, operation, maintenance, management, and regulation of infrastructure, and who need to consider climate change in their projects with their clients. This includes ICI and MUR property owners as well as their tenants. This newer designation should be something that ICI clients request and look out for when they're looking to include in their climate related projects with consultants to ensure at least one team member of that consultancy they're considering, if not more, have this designation and can conduct work on their property going forward. As we were talking about before, this is an example of the Climate Risk Institute's IRP credentialing program on their website. As we go forward, we can look at what the government of Ontario did in terms of their independent review that they pulled. During the spring of 2019, heavy rains paired with melting snow and a sudden temperature increase led to devastating flooding across many areas throughout northern and southern Ontario. Emergency declarations were made by 23 municipalities and one First Nation, with significant flooding impacting households, commercial properties, roads, and other key infrastructure such as bridges. Emergencies were first declared starting in early April and lasted through July in many cases. Even though the fall, Even through the fall and heading into the winter, the Great Lakes continued to experience high water levels that had been underway since early 2017, and many people and properties continue to be at risk today. In response to these flood events, the provincial government announced that it would undertake consultation on the province's current flood mitigation and land use planning policies. Their first step was to host 3 regional listening sessions held by provincial leaders with municipal, Indigenous, and industry leaders in Muskoka, Pembroke, and Ottawa in May 2019. These sessions allowed the province to hear directly from areas most devastated by these spring floods. Acknowledging that these sessions did not cover all areas that experienced flooding, nor provide the public with an opportunity to engage on the topic, the province invited comments regarding flooding and suggestions to make Ontario more resilient to flooding through an online survey from May 16th to June 28th of 2019. The provincial government then announced and appointed Douglas McNeil in July of 2019 to review Ontario's current flood management framework. In addition to considering policies and activities which influence spring flooding, he was also asked to consider both Great Lakes and urban flooding as well. As a special advisor on flooding, Mr. McNeil was appointed by the Minister of Natural Resources and Forestry to provide expert advice to the minister and to make recommendations to the government on opportunities to improve the existing flood policy framework here at home in Ontario. Based on his analysis and community tour over a roughly 2 week period, where he was talking to experts across the province, He made 66 recommendations for the province of Ontario to implement to better protect their residents, its businesses, as well as its infrastructure from flooding. Of those 66, some of the following stuck out. Recommendation 6: a working group with the provincial department, conservation authorities, and municipalities to be developed to prepare a multi-year approach to floodplain mapping. Recommendation 7: the province should consider the establishment of a provincial elevation mapping program with funding approved going forward. Recommendation 17: the province should support municipalities and conservation authorities to ensure conservation, restoration, and creation of natural green infrastructure during land use planning is used to reduce runoff and mitigate the impacts of flooding. Recommendation 28: the province should take steps to regulate drainage standards in urban areas, such as the requirement to restrict runoff flows to pre-development rates and flood protection measures for private property. And if so, what is the most appropriate legislation to ensure that this is done properly? And finally, recommendation 66: the province should maintain at a minimum the current level of funding in departmental budgets and programs related to everything flood, i.e., associated policies, technical requirements, floodplain mapping, maintenance of flood infrastructure, satellite imagery, and etc. Finally, we'll look at Chapter 4, External Groups and Their Initiatives. Examples shown here above are from Barrier Solutions and show uh, elevated levels for backup and outside building structures protected by deployable, and as we can see here with the black joining coupling links, can be joined and made as long as possible to protect key infrastructure and key openings to commercial properties and their outbuildings. So, looking at resilient measures and insurance companies, provisions and various other requirements associated with climate risks affecting the accessibility of insurance policies for commercial properties has received less attention in comparison to the residential marketplace. Born in Klimaswisky Bletner in 2013, compared homeowner and commercial insurance provisions in the United States and argued that less regulation of commercial property insurance facilitated provisions in areas at risk of climate events. As insurers, they had more flexibility to price and tailor their policies accordingly. However, real estate investors surveyed by ULI and Heitman in 2019 claimed that they had seen little impact on insurance availability and costs apart from in the wake of climate events. Nonetheless, these investors anticipated changes in future climate could cause insurance availability and costs apart in the wake of these growing levels of climate induced events. Nonetheless, these investors anticipated changes leading to stranded assets within their portfolios for investors and higher risk uninsurable properties for commercial as well as multi use residential property. Research in the United Kingdom found that increased insurance premiums and excesses were of concern to commercial real estate occupiers as well. Harvard Business Law Review wrote in an article back in 2017 highlighting how the insurance industry can push property owners towards preparing for climate change and in turn become more resilient. An example from the article in the US includes insurance provider USAA, which offers insurance and financial services exclusively to members of the military, veterans, and their families, and it offered discounts to homeowners in fire-prone states who took steps to protect their properties from wildfire risk. Furthermore, insurance premium discounts incentivize owners of both commercial as well as residential properties to adopt and implement various adaptive measures, which keep insurance companies' annual losses lower over time. So, in terms, a win win solution for both sides. Could investors improve insurability and reduce premiums by undertaking investments in resiliency? If so, this could be a mechanism through which asset values in areas subject to climate risk might be protected. Yet, except where mitigation is a mandatory obligation, there is little evidence to date for insurance benefits from resilience expenditure. Interviewees in Lamont et al. In 2019 cited the lack of incentives within existing policies and the lack of lower pricing of insurance and resulting insurance policies are a deterrent to expenditure on mitigation where they're not even offered. To date, it has generally only been seen where mandatory mitigation and adaptation regulations required through insurance markets either private owners or in part owned or funded by government entities, that commercial property owners have benefited from resilience and expenditures to help keep their premium rates low with their insurance. The only other examples are generally found in the residential market, as we mentioned earlier in today's module, offered by groups like the cooperators and etc. across Canada. So an example here on the slide shows increased risk in locations stemming from more frequent and more severe weather events and floods. So this flow chart shows effects on cash flow, effects on capitalization rates, effects on financing, and these effects go as a cascading effect down. It affects your income, your outgoings, your risk premium with your business, your expected growth, your cost of financing, and your availability of financing and insuring your property. And these cascading events go down through these 15 plus different pieces, which can affect your business negatively if you're not adopting resilient and adaptive measures, which can include reduced rent from fall in demand, greater cash flow volatility, reduced insurability of asset or reduced liquidity or saleability of your business asset, higher margins stemming from increased risk for your financing, increased operating and capital costs, as well as taxes that could affect your expected growth, as well as fewer potential equity partners if you can't get that financing and insurance. So, again, when we talk about climate and economy being separate entities, they're actually quite closely tied and are innately intertwined with one another. So making sure you're adapting for increased climate change induced events, as well as increased urbanization and overflow and overland flow of flooding events. This is what we mean by trying to make sure resilient measures are also affecting your ability for insurability, as well as your financing and your business's growth into the next couple of decades. We can also look at what ARUP did with First Street Foundation. ARUP is an international engineering firm who partnered with First Street Foundation in the United States. And First Street Foundation is a nonprofit specialized climate science and flood modeling group who have released several reports since their partnership was first announced in 2017 with ARUP. One of their reports and products they released at the end of 2021 was entitled Their Fourth National Risk Assessment on Climate Commercial Closures as a Result of Increasing Flooding Events. In this report, they note that very little impact of flood risk on commercial properties, and this large percentage of the real estate market, including some large head offices, have already relocated due to increasing climate-related risks. This includes Spirit Air Operations Center from Florida to Nashville, Hewlett Packard or HP in Houston, and Roper Hospital in Charleston. Their analysis indicated that at the end of 2021, nearly 730,000 retail offices and multi-use residential properties were at risk of annualized flood damage in the United States alone, and that this number will grow by approximately 8% in the next 30 years. The sheer cost of this risk for structural damages is currently set at $13.5 billion US annually, and is expected to grow to $16.9 billion by 2052, or an increase of 25%. So this showcases the different damages and the percent change for structural damage to these properties, numbers at risk in 2022, and what those numbers at risk could look at 2052 for structural damage, lost days of operation in light blue, direct impacts going from 26.8 billion to 34 billion, and indirect impacts 23 billion to 29.1 billion. So these changes in categories show that $3.4 million in structural damage could be associated with risk, 1.1 million more combined lost days of building operation for all retail and office buildings, 7.2 billion or more dollars in direct lost output, as well as $6.1 billion in indirect impacts due to downtime days. Or downtime days. So this could mean that this affects your logistical work, your shipping, your transport. All these things are showcasing, and as First Street Foundation shows, this is just from flooding alone in the US. So showcasing that some level of structural intervention and measurements have to be placed on these private properties, specifically within the commercial property real estate sector. Finally, we can also look at the Bank of Montreal and the Institute on Catastrophic Loss Reduction. The Institute for Business and Home Safety, or IBHS, and the Institute for Catastrophic Loss Reduction developed the Open for Business, a disaster protection recovery planning toolkit for small and medium enterprise businesses. The toolkit not only focuses on floods, but all potential disasters that could impact your business and its normal operating procedures. The toolkit discusses how to protect your business's critical resources and assets, and assesses how to develop a continuity plan when facing a disaster event and associated forms with your business plan to stay open, including key contacts necessary, key supplier vendor information, computer data and software, disaster response checklists, and your recovery location for your employees. The toolkit also includes fillable checklists for incident response recovery and restoration needs, and property protection checklists, along with other additional resources and key contact details of disaster recovery organizations across Canada, which you can reach out to for further information. So this example shows here no cost to your business as identified in the toolkit. You can calculate business interruption for 1 week, 1 month, or half a year if a flood were to affect you. You could ask your insurance company about your policy coverage and updated prices if you were to install resilient actions made on your property. You could write up a checklist for your health and safety team to stay on top of possible flood watches sent out by ourselves here at TRCA and other jurisdictions such as the MNRF, as well as warning and where to go further for this information outside of social media and news outlets, and how you can keep your building's flood vents, floor drains clear of debris and blockages to make sure if there is a flood that occurs in your building, the water can get out and expel out of your building as quick as possible to minimize the damage. Whereas the Bank of Montreal, a recent survey was released by their Climate Institute in early 2023 and states that only 19% of US based small medium enterprises SME executives said they feel strongly supported by their government at all levels to establish and pursue climate plans. Here in Canada, though, this drops to just 9% of SME businesses. Although government intervention is necessary, not all support associated with climate change planning and implementation of actions can come solely from our governing bodies. The BMO survey found that a good number of SME leaders saw opportunities to partner with their associated financial institutions or banks to overcome some of these challenges associated with developing a climate plan. 7 in 10 businesses within the US and Canada polled said financial institutions, meaning banks, credit unions, lenders, etc., could help them better in aligning their business with climate change objectives set either by the government or their local municipalities. In the US, 27% of SME leaders said their associated financial institutions are already playing this role. Meanwhile, 17% of SME leaders stated their financial institutions and their Canadian counterparts, uh, and nearly half of business leaders felt financial institutions could do more. In the US, more than 80% of SME businesses say they are interested in any insights they could get from their banks and financial institutions on how to start to address climate change on their properties. And this could include discounted loan programs to help cover their costs or discounted approaches on how to create more resilient adaptive measures on their properties. The image above here shows physical impacts of climate change for these SME executives. So 69% of responding executives expect the physical impacts of climate change will disrupt their business operations over the next 5 years. 8% said they don't know, 11% said it won't affect my business, 2% said more than 15 years from now it's way out. And as you go along, the highest percentage said 30% it's already impacting my business. The second and third highest said it'll happen within the next 3 years of my business. And 15 said it'll be happening within the next 4 to 5 years. So not the next decade, not by 2030. A lot of these businesses are already being impacted by climate change induced impacts. And a lot of these are around flooding. One of the final pieces we'll be touching on today is a report by the Intact Center on Climate Adaptation, or ICCA. This is one of its first of its kind in Canada. It was supported by the Building Owners and Managers Association, or BOMA, and the Real Property Association of Canada, or RealPAC, which represents owners and decision makers within the commercial real estate industry. The report discusses best practices for planning and procedures, equipment and supplies that should be installed on your property or within the building itself, and even major retrofits required if the property in question is located in a high risk location like a floodplain. The report includes several case studies and real world examples in Canada's commercial properties taking resilient and adaptive actions, as well as implementing various measures to better prepare their tenants, their building operators, and management staff, as well as purchasing flood walls, berms, low impact developments, and other third party installations we mentioned today. The report also discusses what various companies use to better prepare themselves in the event or in the likely event of a major flood event occurring and how they prepare for flooding now that they've already been affected. These include CBRE Canada and Infrastructure Ontario. They use the Weather Service Provider, which shows provincial buildings within Infrastructure Ontario's portfolio who are warned through Environment Canada's public weather alerts and goes out to all affected building member staff on site or in the field to ensure they are prepared for a major flood event. Whereas Infrastructure Ontario, in its design guidelines, they use the retrofit of building water detection sensors that should be installed under the raised floor of a computer room where AC units and HVAC systems are being installed. If flooding occurs, sensors trigger a water leak detection alarm, and facility managers and operators are informed instantaneously. Evergreen Brickworks, which we'll touch on more in our final module, developed numerous flood adaptive and resilient measures as included in their flood management by design and by protocol. They used Cupolex to raise floors above the 10-year flood lines. They installed green roofs. They installed floodgates at entry points around head office buildings' major entrances. Where they have children's play areas, they had closets and benches built above the 10-year flood lines to ensure the children's property and their bags didn't get damaged. They also integrated a flood preparation checklist into their daily standing order for activities to be taken on site. They also developed a relationship and partnership with their local watershed authority, meaning us at TRCA, and our flood duty officers, as its location is located within the Don River floodplain. They also included a flood risk clause in their tenants agreements, as well as third-party event agreements to ensure they are both aware of the risk they are taking while being located or working on their property. The report also spawned the development of the CSA W21021 CSA document for flood resilient design in existing neighborhoods and buildings. Now we'll be looking towards our next steps. Our final module within this series is Module 4, the use of low impact developments and green infrastructure to help manage on-site stormwater management risks in commercial properties. And that will finish our Module 3 for today. Thank you very much for your attention. And if you want any more information about this initiative, you can visit the Partners in Project Green Resiliency and GI site at the link below, our Sustainable Technologies Evaluation Program site, which you can link below, and our TRCA Flood Risk Management site, which you can see below. If you have any further questions, you can refer them to myself, Daniel Filippi, Research Scientist at STEP, or my colleagues Chaya Shagapa and Darlene Coyle at PPG. Thank you very much for your time, and we hope you enjoyed the module.